it and what uses does it have, and what tools the ArcGIS will give you for processing that kind of data. Okay. Yeah, did you stop sharing or you? I mean, sorry, you did not stop sharing. No problem.
Yeah, 1 second.
Okay. So where is whiteboard here?
Sir,
Yeah.
sir, I have one doubt that in my data, why that they are coming like 27.9 like that? Why they are not coming 1 2 3 for the after
Array,
hellos?
wait. Uh, See, that is the when you did not when you entered the data, when you tried, say suppose you gave sample data, right? You gave sample
Sure.
data. Okay. When you give sample data, you have to there is a column called value. In that value, you have to mention
Yeah.
that this is only uh, 1, 2, 3, 4, something like that. If you don't do that, you get this
Sure.
kind of errors. Wait, let me show the raster. No exercises. 137. Um, okay, this thing. Place type. Okay. You have clip also in this thing? Yes, clip data. Yeah, I think now clip data. Yeah. Okay, I'll share that. Where is the sharing of data? Hunted in ArcMap. Okay. So if I is there this? Okay, what is this? Acha, okay. Uh, image classification. Okay, so if I have this thing, imagine I take this thing. Okay, I randomly take uh, that as urban. Okay. And take this as water. Okay, let's say something else. This as vegetation. Okay. Now, because I have value 1, 2, 3, if I do classification, it's gonna take 5 minutes. No, God. Okay, so I have this thing. Now, if I go look into the attribute table, I have 1, 2, 3 values. Okay, agree. So now, if uh, I do that, I do this, the pixel value will be 2, urban class. Okay, this is blue, pixel value is 1, which is 1 here. Okay, the pixel value is 1, the 1 is here. Now imagine I don't do this, I change it to uh, change this to 10, 140, 200, 20, 27. Okay, now I do that, I do interactive classification. So I have this thing. Now I have attribute table. You see, values are this thing. Agree? Here you have the
Sure.
value of the color you used. So now if I go check that my not this thing. Uh, layers, select layer, red. Pixel value is 200, 140, 200. Yes, 25.
Sure.
Somewhere I saw 25. 25. So that is all. Based on this thing, you get difference in values. So that is all. Understood?
Sure.
Okay, so Can I go to whiteboard now? Okay, so stop sharing. Actually, sir showed me where is the whiteboard. Oh, yeah, the
Is
whiteboard
there? Yeah.
is whiteboard. Yes, whiteboard. I think I will share the whiteboard section. Yeah, I hope you're seeing something is rotating. Okay, let's see. Yeah, yeah. Can I erase this thing? Where is the eraser? Is this the eraser? I'll take the eraser. Let's go. Let us take a pencil. Okay. So, what is the essential concept behind watershed delineation? Earlier, we used to have maps. Okay, we used to have maps with contours. Okay, with contours like that. Okay. So this contour, so we realize that okay, if I this is 250, so suppose this is 50, this is 300, this is 400, this is 600, 600. Okay, we had this notion. So based on this, if rain falls here, I mean there are droplet that is here, the rain falls here. Because we know the slope, we can calculate that the river water comes like this. Okay, the river water comes like this. Based on that, they said, okay, this is the river stream. This is how the river stream is going. Okay, there are tributaries. There are like that, 1, 2, 3 tributaries. Like tributaries like that. Okay. Then what they did, they wanted to calculate the contributing area. Matlab, you have this entire region. Okay. Now what they are interested in, okay, see if I take this tributary here, okay, how much of area from this entire location or the entire landmass I have is actually contributing to this river or this tributary. So what they did, they used to have this same process. Matlab, how do I explain? Okay, they went back like this from 250 to 300, 300 to 400. They went back. They found that at a particular location, if I have a contour map like that, at a particular location like this. So this is the stream. Okay, this is the stream. This is the stream. Okay, at a particular location. I am bad at using this board. Ah, my God. Okay. At the particular, this is the other stream. This is the other river. So maybe I'll use this for rivers. Yeah, it's a river. So that is the main river. Okay. So now they found out that when they went back like 300 to 400 to 500, 600, something like that. Okay. At this particular region, if I put droplet here at this particular region, the droplet can go here, this side. Sorry, mistake. I'm so bad at using this thing. Yeah. Need some practice, so please bear with me. There it is. So at this from this location, the water droplet can go either this direction or this direction. Okay, like that they made points. Like that they made a points, and then they joined. They got a block. They got a small landmass or a boundary. Okay. Now they labeled this boundary as watershed. Okay. They labeled this boundary as watershed. So wherever the droplet rain falls in this inside this boundary, that all the water will end up here. Okay. There are underground channels. There are soil absorption. There is plantation, I mean crop uptake, there is everything. There are ponds, there are lakes, there are dips, there are depressions, all of that. After all of that, the water will finally end up here in this direction. And it will flow into the stream. I mean, whatever the stream or river or tributary. So this section is called as our watershed. Agreed. Am I clear till now?
Yes, you are.
Yeah. So, how can I erase everything from the paper? Do anybody know? How can I
Erase.
just
You pick up
no,
the.
not like that? Can I? That is too much of a headache. Like, oh yeah, not so much also. Fine. Okay. Ma'am, Kapila ma'am, you're not talking.
Yes, ma'am. Yes, sir, I'm hearing. I'm listening
Okay,
to you.
okay. Because suddenly you will drop out. We don't know.
No, because of the connection. It'll be
Ah,
sometime
that's
back
what.
also it was disconnected.
Okay.
I again connected.
See, I'm recording it so you can download it from the Teams.
Sir, I'm not getting that. Where should I download? Because that from the raster, this thing, I haven't downloaded anything.
See,
So
you
I'm
are seeing this
not.
CGSRT class 8 to 10.
No, I am not getting this Teams only. I'm just going through the link. No, so like.
No, look, madam, you're added to the Teams. See, in this team, you're added here. In
Oh,
this,
AGSRT classes, no?
I added you as a member. You're there in the member. So if you go to this AGRT class to 8 to 10, you will get this chat, this
Okay,
post.
okay.
From this, you can
Okay,
download.
I see.
Okay, fine,
Okay.
fine. So that is out of the um, way. So now we can actually concentrate. So, so they used to do this before they understood, before they got remote sensing data, something like that. Okay. So so for imagine, let us take Krishna River Basin. Krishna River Basin is like that, like a apple. I mean, how is that so bad at this? It's like really, it's like that. That fellow goes here and array, yeah. Control Z. Do we have Control Z here? No. Anyways, that was bad. Anyways, so we have the Krishna River basin like that. Okay, I hope that is the mouth. I mean the final. This is the India eastern boundary. This is India's uh, western boundary, like that. Okay, so in the middle, the Deccan, you have this Krishna basin. So they started visualizing all of this thing through survey maps. So they had this Bhima river coming, they have this Tunga river coming, they have this Bhadra river coming. They had different streams like that. Malaprabha, all that was coming here like that. And then they finally made into a huge stream. Okay, a huge river like this. This is Krishna. This is Krishna from here like this. Okay. So the Krishna goes like that, goes like this. There is another Musi river here, Mahanandi, something like that. Okay, two, three rivers are there here like this. Okay. So how? So they did this kind of massive survey using survey tools, cartography tools, based on the terrain, based on the altitude, based on different aspects. They created this kind of charts, very detailed charts for calculating the watersheds and all, so that because one thing is one peculiar thing is Hyderabad is here. Okay, this is very interesting. Great. Now this is Godavari River Basin. Above this thing is Godavari River Basin like this. Array. This is Godavari. Godavari River Basin like that. Okay, maybe I'll use a different color. Yes. This is Godavari River Basin like this. Great. So Hyderabad falls between these two basins. So southern part of Hyderabad gets water from Nagarjuna Sagar or any other part in the uh, Krishna River basin. It has the right. The northern part of the Hyderabad receives from the Godavari basin. Okay. Now they started doing all of this for various purposes, but one of the interesting use of this thing is this particular thing. How do I know where to give water from, or where to construct dam? If I want to construct a dam here, I need to know what the flow, the amount of water coming, where it is coming, the watershed. So all of that information is required. So they did all of this thing, and it is also very essential for them. Then dawned the remote sensing images. Now you need to understand, I cannot do the same thing through hand in remote sensing. Okay, I need to use the images. Okay, now I'll explain you the basic concept how the image works. Okay, remote sensing image work. Please bear with me in this thing. Maybe I should turn it the pad this way. Okay. Or I can draw it this way. No, I cannot. So I think I should use a scale for my sketch to work. So if you people have any better idea, how can I improve my drawing skills, please? Arey? Oh my God, this is so bad. Oh my God. Anyways, so, so basically, I'm sticking my pencil to the bottom part of the image with the pad and I'm screening. Oh yeah, this is so good. Oh, this is so nice. So I can use this way. Okay. So now if you see, this is my image. Imagine this is my image. So this is so the every raster image. Okay, it has a pixel value, has a pixel. Okay, has a pixel value like that. So in for this kind of analysis, we excuse me, I have experiencing some. Oh God, my face. Give me 5 minutes and bring some water and come.
Okay.
Sorry, I had experienced some mild dizziness right now. So
Everything is all right.
yeah, at least now I am all right because I just had a vaccine in the morning.
Okay, okay.
Just experiencing that nausea, I mean, not nausea, but dizziness. But anyways, if I get any severe thing, I will disconnect. Okay, by that, but I can continue till that time. Okay. So this right now, what we are using is DEM. We use digital elevation model. Okay, DEM. DEM. DEM data for doing this kind of watershed analysis. What has the DEM has the elevation. Oh my God. Okay. Then has the elevation data. Okay, like if it is in meter, it will say 30, 40, 60, 70, like that. So the pixel value here will be the elevation data. Okay. So let us say this is 1, this is 3, this is 10, this is 12, this is 15, this is 20. Second is 20. Okay. Oh, no. I didn't like that. Okay. Let us say this is 56, 64, 64, 78, 92, 84, 84, 70. Then comes 40, 34, 52, 69, 72, 60. Okay. Then comes 30, 26, or else probably 38, 92, 102, 300. Okay. So why am I doing? So this every pixel talks about the elevation. Now imagine I put a droplet here. I put a droplet in this pixel. Okay. Where will that travel? Where will that travel? I'm asking a question. Which pixel? Because this is elevation.
From higher to lower pixel.
So yeah, this the value of this pixel was 56. From that, where will it go?
So downwards, what vertically downwards?
हाँ कौन सा पिक्सल पे जाएगा कौन सा
40,
written no
40, 30.
40 30 yeah. Which one? Explain properly. Think.
First it will go to 40, then 34, then 30, then 26.
नहीं यहाँ से इधर आएगा या इधर जाएगा वो मैं पूछ रहा हूँ. Which is the lowest here?
Sir, that one is 56. No, the upper one.
This is 56.
Yes, sir.
Will the water droplet from here go here or here to here?
So it can go both ways because both are lower than that.
True. That is actually the fact. Okay. That is actually the real world example. It can go here like that. From here it won't go like this. This can come like that. Okay. From here, there is no other option. Okay. It has to go somewhere here like this, down below. Okay. Like from either this way or this way or this way. It has to go in any of these three directions. Okay. So if I put a droplet here, it will come like that. It has no option. It has to come like this. It will go like that. It will go like this. It will go like that, and then come here. Or else some portion will come down like this and go like that. Okay. Agreed? Am I clear?
Yeah.
Yes, sir.
Yes. No. What?
Yes, sir.
Okay. I will erase all of this thing. Okay. Now let me redo this in a very neat way. Okay. At least I'll try. So we understood that from the higher ground, because we have pixel values, the droplet will travel either this way, this way, this way, this way. In the 8 directions it will go. In 8 directions it will go. Okay. Any of the 8 directions. Okay. Based on the pixel values. So that is why this is called as. So every the system, how does it analyze? How does the system understand is, if it, so every direction is given one value. 1, 2, 3, 4, 5, 6, 7, 8. So 8 directions, it will give one value. I hate my games. ऐसा करो. ठीक है. So these are 8 values. So whenever from one pixel, how does the system know? How does the system know from where it is going? How does it know? It says that if the pixel is going this direction, it will say, okay, it is 3. Okay, so now I have an image like this. I have a pixel value. I have pixel values. I have pixel values. Okay. Now the system will generate another intermediate raster. The system will immediately generate. Oh, okay. So that is how it deletes. The system will create an intermediary image. What does it do? Now the pixel value will not represent the height. The pixel value represents this value. Okay, the number 3 or number 2 or number 1 or number 3 or 4, something like that. So the pixel values will be 1, 3, 4, something like that. So the system will understand that, okay, the direction from this pixel, the direction will be this direction. Okay, 3 is east direction. From east, southeast. Okay, or something like that. So the system will understand, okay, this is the direction of the flow. Okay, then comes calculation of the flow accumulation. Okay, calculation of calculation of the flow accumulation. So now the system knows that, okay, why this not working? Okay, the system knows the direction of the river flow. Okay, the direction of the river flow. This is how the system will understand the direction of the river flow. Agreed? The direction of the river flow is understood by the system in this manner. This is how the basic concept runs. Agreed? After this, now system wants to calculate which, okay, there are millions of streams. Okay, because the Krishna River is a huge basin. There are millions of streams. Okay, I mean, even system will calculate even the smallest movement from one pixel to other pixel, it will calculate. But how will the system know what is river and what is not river? What is a stream? What is a tributary? How does the system know? Can you please people think logically and tell me how do a human know that this is tributary, this is main river, this is stream? Can you please tell me?
The first order ones where it originates will be the tributaries. When
You are talking in technical terms.
okay.
First order, second order, third order, technical terms. Okay. I am not asking that. As a normal human being, how will I know this is river, this is stream, this is sub tributary, something like that? How do I know? How do I know the concept? I mean, I'm a layman, I'm a farmer. How do I know?
If it goes in a branching manner, then
It goes bouncing up.
if it goes like 3 branches, then he can.
Can you be clear?
If something is separating like a nala from the river, then he can conclude.
If something is separating from the river as a nala, you
Yes,
can
sir.
conclude.
No, basically the size of the stream, width and depth, like
it will get
Yes.
narrower. No.
Yes.
the smallest nala will be in
Yes.
the first order. Then as it goes higher,
Yes.
its capacity and the
So
width.
how much water is flowing through that particular thing is what makes us think that, okay, this is river, this is stream, something else, right? Yes.
Yeah.
So
Yes.
system also does the same thing. How does it do? Based on the now from the height we have the flow direction. Okay. We have the flow direction. Now till this point, the system will calculate how many pixels are contributing to this particular stream till this point. Okay. For example, from here, from this pixel to this pixel, there are 1000 pixels contributing. Okay, 1000 pixels are involved. 1000 pixels are involved. Okay, for the water coming from here to here. Okay, so the value of this pixel will be now 1000. Okay, will be 1000. Imagine this stream is also there. There are 2000 pixels from here to here. So the what will be the value of this pixel now? 1000 plus 2000 is equal to, I'm so bad at this, 3000. 3000. Okay, agreed. So that's how the system will calculate. This is called flow accumulation. Flow accumulation. This is called flow direction. Okay, flow direction, flow accumulation. Based on the flow accumulation value, the system will now say that, okay, if I give a square image, the entire I give like that, the system will now say, see, this is the major river. This is the tributary. This is another tributary. Okay, that's how the system will say. Agreed.
Doubt here. So in natural situations, in nature, sometimes what happen, tributaries and distributaries will be having flow. Okay, when it reaches the stream, it would be totally dry. Okay. In that case, how the system will calculate?
No. You are talking about flood and non-flood period or dry periods. The
No,
system will not.
any normal time also, even in the rainy season also, sometimes what happens.
Let me explain. The system will not take into consideration the flood and non-flood or whatever rainy season. It will not take. What does it take into consideration? There is a high elevation pixel, there is a low elevation pixel. That's all it takes into consideration. Agreed?
Yeah.
If I put water droplet on every pixel, where it is going, that's all it calculates. Okay. That is up to you to mention how much flow is coming, how much flow is not coming. That is based on the precipitation data you give to this processing. It is after this thing. Okay, that comes with analysis part. Now what we are still at digitization or delineation of the watershed. Okay, we are at only the delineation part of the watershed. Okay, so the system will now calculate that this is the flow accumulation and all. So based on this value, we calculate. Now what the system will do? Because see, to coming to this point, or let's take this point and this point. Okay, to come for the water droplets from like how they delineated the watershed old in the old techniques, the system will use the same logic. How many pixels are actually contributing to this particular area? What area the pixels are spreading for this point to have the water here? That is called sub-watershed. There is sub-watershed here. There is sub-watershed here. There is the main watershed here. Okay. So like that. So system will say that, see, for this particular flow accumulation to happen here, the quantity, all these pixels are contributing. So this becomes the watershed of this particular river or stream. Okay. So based on the elevation, it does it. Now, that is the basic concept. What I taught you is an extremely basic concept. But this is how it works. The system will work. Now you need to understand certain aspects, like what errors can arise when you're doing this process. What errors might arise? For example, let us take this is the terrain. This is the terrain. There is a small ditch like this. Then there is a terrain. Okay. Now, if I have a water body like this, First, the water travels like that, fills this ditch, fills to this level, and then the water will carry forward. Yes, that is the normal phenomenon. Agreed? Yes or no? Hello?
Yes.
Yes. Fine. I think you did not have your dinner. No problem. So we have that. Similarly, we also have the data also has these kind of errors. As in, for example, I have pixel. One pixel value is 32. One other pixel value is 64. So from 32 to 64, if the pixel value is in the middle, that's slowly increasing. 32, 40, 56, something like that. Then how do you imagine this? Just imagine if the pixel values are like this, how will be the terrain? How will be the terrain?
Highly uneven terrain.
No. Okay, that is true. That is true. That is uneven only. But what is happening to the terrain?
It is like dome shape.
Forget dome shape, that shape. What is happening? I'm just simply asking what is happening. If I'm traveling from 32 to 64, what is happening?
Height is increasing.
Climbing up.
Perfect. Height is increasing. How does the terrain look? The terrain will look like this. Yes, this
Yeah.
will be 32. This will be 64. Agreed? So this is how the terrain looks. Now imagine there is another example here. 32. I will this one. 40. Suddenly there is 16. Then 64. What happens now?
It is valley.
Sort of like that. Yes.
Hmm.
Agreed? So that is how the system will know where are the ditches, where are the peaks. If suppose instead of 16 there is 78, the terrain will look like this. Yes. So the system will right now, that's how it calculate if there is a peak or a ditch or a small ditch like that. But in some cases, due to the system error or also the terrain is like that, we get these things in the watershed delineation terminology. These things are called as sink, S-I-N-K, sink. Okay, these things are called as sinks. So if I use this data to delineate my watershed, my river network will come like this. Imagine this is the main river. It will have the random branches like this. Random. I mean, it looks extremely unrealistic. I mean, that is actually the realistic part. It looks very weird. I mean, extremely clumsy, very, what do you say? And it is very hard to delineate this kind of network. Okay. So what do we do? What do we do? We use a process called, I think I should take a bigger pad next time. What is this? The eraser is not working. Why eraser is not working? Oh, this is bad. Why eraser is not working? Oh, you can increase and decrease also. Very nice. Second, I will try to figure out why this thing is not working. Come on, come on. Anybody has any idea? Anybody has used this whiteboard till now? No. Okay. Oh, so only this. Oh, this is not working now. Wow. Why?
Sharon, network connection is poor, I think. That's
Why?
right.
Hello? Hello?
Yes,
Yeah,
sir.
yeah, you're audible.
Your network.
I am doing in my system. How is the network? Is it for help
So
here?
it in there.
I mean, this is weird. Anyways, good. Even this is not working. Now the pen is also not working.
You open new one.
See, you know. Oh.
Plus you please add.
No, it still says add a tab. It still says the same thing. Right? Right. Good. You can just add tools to that. Plan or Zoom. Okay. Maybe we can do that. See, that is working. This is not working. What? Oh. Let's see. Okay. Some error is there with the app. I cannot help it. My God. I mean, don't like this thing. Anyways, how do I tell you? How do I teach you? Now then. It's like right now how my brain is working, it is working like that. Come on. Delete. See, pencil is working. The app is not okay. The app is not working. See, the app, this only the pencil part is not working. Rest all it's working. Even the selection is working. Anyways, so how do the system handle this thing is, we do a process called fill sync. Okay, so we average. I showed you, right? There is a sudden dip or sudden rise in the pixel value. Yes. So we say that okay, the system identifies these things as sinks or elevations, and say if the right side, left side, top and bottom pixels have an average value of 30, but the middle pixel suddenly has a value of 100. The system will understand, okay, this is something wrong. And then what does it do? It clips that value. It averages based on the border pixels. It averages the value. It averages the value. And now, because the average is the pixel value will come down to either 35 or 36, something like that. In that scenario, we are filling the sink or cutting the elevations. Okay. We are
No,
filling the.
is that a realistic thing or just it's like the peak which value which you are getting or the low value which we get is a real representation of the nature or it is as anything related to error or something? Like
See, based on the resolution, for example, okay, let us talk about the data we have right now. Okay, we generally use Astrodem, SRTM, or Cartodem because these are free. These are all 30-meter resolution. Cartodem is 5 meters, I guess, 5 meters or 10 meters. I forgot. So based on the resolutions, system might identify the real scenario, the surface, or it might be because of the random error caused by the data. Maybe the reflection. I mean the SRTM works on microwave, so there is scatter problem was there. Some issue with the data collection can also be there. But in some cases, even the real terrain also causes lots of problems when you do analysis. Okay, that is the reason why we smooth out the entire terrain so that it will not drastically change the real world value, like the flow or the what do you mean by flow? Not flow, by the river stream direction. Like it will almost it will be fitting on the if the river is flowing in particular direction in the real world, the simulated river network will also fit in this. I mean, almost, not always. It will go on the same path, follow the same path, same direction, same curvature. Everything will be almost same. Almost, I will give it to 75%, not even almost 70%. Fine, it will work. Okay, why? Because we smoothed out the terrain. Okay, so that we'll get a proper analysis. I still all of a sudden stop. Can I create a new page?
Yeah, that would be better.
Can I erase now? Oh, finally. Oh, thank God. So the system averages out the data such that these dips or these peaks will be smoothed out like that. Okay, will be smoothed out like that. And how the pixel value will look now? Same, like 32, 40, 56, 69. It will look like that in a very straightforward fashion. Okay. Now, now there is another concept that we use. So there are two types of process we use for watershed delineation. One is dendritic and one is uh,
Trellis.
ma'am,
Trellis, right?
derange. Yeah,
Ah.
sort of thing. So what do we do? In dendritic, we go forward, like we have a dem data, like how we did dem data, we process the data, we get a flow accumulation, get flow direction, flow accumulation. From that we analyze. In derange, we do something else. We already have stream data. We already have a stream data. Okay. What we do is we use that stream data to correct all the errors, to correct the errors that are present in the dem data. Agreed. So we already have a reverse stream network data, and we use that reverse stream network data to correct the what is called as DEM reconditioning or data reconditioning. So we have that we recondition the raster data such that it will give me same values like the stream data used. So based on that also, so it is a reverse case. You're just going down to top, top to top to down, or down to top. So that is
Like a validation you are doing.
yeah, we can do that. Yeah. So the D range is basically first you clearly I mean rearrange the DEM data such that it gives me a correct stream network, because I already have the stream network. Okay, so we reorganize, or what's called reconstruct the DEM, or just change certain values of DEM pixels such that the DEM value will give me the exact stream network that I have. In that way, we can do. That is called reconditioning of the DEM. That is one process in ArcGIS. So we can do that way also. And one more thing, what I want to share. I forgot. When you are doing DEM analysis, okay, you need to understand two things. The system doesn't know. The system doesn't know what flow accumulation. This is river, this is stream, this is nala. It doesn't know. You should specify this value. If the stream network is 1000, or stream accumulation is 1000 in that pixel, then that pixel is the most important thing I want. Based on that only, the system will calculate this kind of reverse and all, reverse streams and all, it will calculate. Okay. And then the system will, after flow accumulation, the system will do watershed delineation. For every junction, you can create a watershed, sub watershed like that. Agreed? So you will get finally the entire watershed of the river network. You will get. You can convert that polygon into sorry, that raster to polygon, and you can do your analysis on that. Okay. So this is this is very simply, this is the concept behind watershed delineation and how the system will do it. So when you are trying to do a certain process, now you will have the idea. Okay, this is what I need to do. This is what is happening behind the screen. Okay, so that's that. So let us jump into our uh, uh, stop sharing. Now I will start sharing. So we are recording this file, right? Because yeah, and what? So sir is not here. I don't want him to miss this. Okay, so share. Okay, this thing. See, this is what I wanted to show you.
I guess the whiteboard will not be recorded.
No, seriously.
I guess so.
No,
Think so.
that is very bad. Oh my God. Anyways, got it. Now, at least.
But audio will be recorded, right? Sound.
Yeah. Clear flags. Okay. We'll remove all of this thing. See, I have already done this thing because delineation of a particular thing takes around, at least for Krishna Basin in my system. In my desktop, it took me my system. My desktop is pretty powerful system. In my system, it took around 40 minutes or I mean 1 hour it took to delineate for the entire Krishna basin. So I do not want you people to do delineation for such a large water body. Take one DEM image. Just take one DEM. Matlab, uh, if you go to USGS, okay, like how you downloaded Landsat for one row and path. For one row and path, you downloaded an image, right? Like that, just download one DEM path and row image and try to process it. It will be faster. You will get more doubts. You will learn faster and you will, because you have a smaller image, the system will run it very smoothly. Okay. Please do not attempt for such a big thing right now. Okay. But I'm just sharing you my data set.
One DEM is around 750 square kilometer, right? One sheet. Well, it's
Yeah.
the size of one topo sheet. Degree
Yes.
sheet actually.
Yes. 30 meters resolution का है. And right now, yeah, I think that one, but I really don't exactly know what is the span, I mean, swath of the data. Okay. So this is entire South India. Now, how did I get to entire South? I mean, not entire South India. There is no Kerala and Tamil Nadu. At least the Deccan till Krishna Basin. Now, how did I get to this part? I went to where is my Tarun classes. Tarun. Waters. Oh, wait. I don't have to do this. I stored it in Art. I wrote it. Yeah. Control. Array. Did I delete entire stuff or what? I use my mouse right now. It's easier if if I lost that, it will be a problem. Anyways, let's try. Oh my God, my decision is in progress. I did that. I got it. So you have this. Am I sharing my screen? Yeah, I'm sharing. Yeah, okay. So that is the entire data set I downloaded from USGS Earth Explorer. Collapse all layers. Okay. There are so many files. There are so many files. Now each file, remove that. Remove this thing. So do that. Okay. So each dem. So I want you to do this thing. Take one dem like that, one dem image. You can clip also. When you say, sir, my system is not handling this one image also, you can only clip to this particular region. Like so, this is river network here because you can clearly see that this white is highly elevated area, blacks are low elevation, grays are medium. Okay, so you can just clip till here, and then you can process. Okay, so this is the entire data I downloaded for the entire my study area. Then what did I do? I used this tool called mosaic tool. See, I think I will show you the entire raster, the toolbar, okay, so that you will understand what else you can do. Where is raster? Yeah. So this is the entire raster data. Okay. This is the entire raster data processing toolbar. So in this thing, you have mosaic, raster catalog, raster dataset, raster processing, raster properties. If you say clip, the clip is here, the tool is here. When you search clip, the tool is this thing. Okay. You saw this composite bands, right? Like you have band 1, band 2, band 3. You make to enter the entire one band, one image where you have all the bands. That is this thing. If you want to pan sharpen, you can do pan sharpening. All that is there here. Extract, subset. Subset is nothing but clipping. So if you have a vector, you can subset. Resampling is also very important. What is resampling? Okay. For example, you are working on Modis dataset, which is 1 kilometer. Then you have Landsat dataset that is every pixel is 30 meters. Now you want to combine those two images. How do you combine? The pixel sizes are different. Or else not combining, as in you want to compare the classification between these two images. So you have a problem now because that is 1 pixel, 1 kilometer pixel, you have 30 meter pixel in Landsat. Then you come here and you use this resample thing. Okay, when you use the resample thing, you give the raster data. See, always do remember one thing. You need to resample 30 meters to 1 pixel, 1 kilometer. You cannot resample 1 kilometer to 30 meters. Okay, that is wrong way to do. You
It
should
does
always
average
convert.
also, right?
Ma'am?
It won't average also. It is just like going to the
Yes. You
least.
make the value will be split into several things. That's all. You will not have actual real value. But if you convert from 30 meters to 1 kilometer, it will come, it will mix. For example, if 30-meter values will be there, no? The 30-meter value for all that kilometer, it averages.
Yeah.
Or else, depending upon your request, maximum, minimum, standard deviation, whatever, it will average to one kilometer and give you a much better value to that resampling. So you select the raster here, you give the output raster here, you specify the cell pixel here, your cell size optional. I mean, actually optional, you have to specify it here. 30 meters, 1 kilometer, 250 meters, whatever. Okay. Similarly, there is one example I want to give you. See, when you're processing, this is 30-meter depth. Okay. It will take exactly 1.5 hours or 1 hour 45 minutes in my system to process this thing. Okay. But if I resample the data from 30 meters to 90 meters, okay, so I give the pixel value as 90 meters and 90 meters. Okay. If I do that, my process will take hardly 10 minutes. So that kind of variation will occur if you do resampling. Okay, and you can choose the process. What is nearest bilinear cubic is based on, see, nearest is the closest pixel value will be taken. Okay, bilinear is it will take an average of the all the surrounding pixels. Okay, cubic is it will take like rather than just surrounding boundary, it will take three more pixels. 3 pixels. I mean, like this is, imagine this is the pixel. Okay, wait. This is the pixel.
See, we
Bilinear will take these pixel values and puts the value here. Okay. By cubic is it will take all these values and then puts the value for this pixel. Averages out and puts the value for this pixel. Like that. So you can generally people will go for nearest. The more you choose bilinear cubic, the image becomes much more smoother. You cannot identify the variation. So people will generally go for nearest because it produces sharp images like this, white versus black contrast. But it has its own disadvantages also. But choose depending on your. But I generally use nearest. It has helped me a lot. So you give this 90 to 90 meters, centimeters. Okay, and you can resample. Agreed. So similarly, you can do split raster. You can from multi bands to single band. You can do. You can also add. See, you can build different processes. You can do get value of the cell. All these are basic stuff. Just go through this, you will understand. Okay. What we are using currently is this thing, mosaic to new raster. Okay. We are trying to use this mosaic to new raster, which also you find in this thing. Mosaic to new raster. Basic, all this thing, same thing. Okay. So if I do that, I input. So now what do I do? Say I have so many files, 1, 2, like that. I think I have around 75 images. So I just have to come here, I click like that. Click. So I input all the data. I select the output location. I select the raster dataset name with extension like mosaic.
Here each pixel value is actually the elevation, isn't it? Precision of
Yes.
elevation.
Yes.
Not that spatial resolution what we get. Spectral isn't it?
Yes. Yes. This is only elevation. This is called
Elevation.
dem. Yeah.
Okay.
You can always use them to create tin data for your arc scene. Okay.
Arc scene is I could not follow exactly. I really need to rewatch that video.
Yeah, you practice it. We will
Huh.
do that if you want. Okay, I'll clear your doubts, no problem. So spatial reference, you always give like either whatever you have, you give. This thing is very
What does
important.
that mean? What special reference you have to give there?
Right now it is in decimal degrees. You can give it anything in the depending upon your location. You can give a UTM zone, anything you want.
Okay.
So spatial reference of the raster is that this is one property you have to always remember. Okay, you have to write. You are merging any these data sets, right? You just right click on one of the data, go to properties. When you go to properties, you have this general source. Yeah, this is the pixel depth is 16-bit. Okay. Right now, when you you also should use 16-bit here. Okay. And it is signed integer. What is signed integer? You have negative and positive values for values and heights. Okay. So you should specify that 16-bit signed integer like this. You have this. 16-bit signed. Okay. Similarly, the cell size is mentioned here because this is decimal degrees. The cell size will be like this. You just have to copy this, paste it here. Okay, and because this is dem, you will say only one band, one single band. Okay, it is not RGB. Okay, it's just panchromatic, which gives elevation data. So you just have to set one. Okay, and that's it. You have to run. Now, if I run it, it will take a lot of time. So I will run it. That is the reason why I have already put all the data here so that we can complete this thing. Okay, okay.
To clip a small watershed from this, I need a boundary file or I can mark it here and take out. See,
I didn't understand, madam.
see, I have to take only one stream from this. Okay. So to clip that much area, I need to have a boundary file to clip out that, or I do have a method to take out only that portion from a
Same
div.
thing. See how you did for land use classification and you clip the data. No?
That I
You can do
needed a.
that. For
Okay.
example, we have this data. Okay,
Yeah.
I mosaiced it. Now you are trying to only work for this particular stream here.
Yes, yes.
Okay, what do you do? Just draw a box here and clip it.
Okay, okay, fine.
Okay. But I think you have an idea, no? Where the streams are, where the stream. See, all you have to do is zoom in. You will understand. Oh, so there is a stream here. This is the
Yeah, yeah.
Dindi river. This is the main Tungabhadra river. This is Shishalam reservoir. This is
Mm.
Nagarjuna reservoir. So this is Dindi river here. This is so you understand, right? When you see a map, you'll know exactly. See, you can literally figure it out where the streams are.
No.
For the data. So you can work it out. I mean, that's easy.
Mm.
These are elevation. These are low. See, you see here. You see here. This image here. So this
High
part.
contrast.
This is slightly sloping down, but this thing is deep
Drastic.
dive, little deep dive. Oh, I forgot to mention this with you. The system also needs slope data because the system has to calculate from this particular region where is it going and which direction it is going. Okay, for that we need to supply two types of data: slope and aspect. Okay, I'll use the whiteboard again. Uh, Stop sharing, start sharing. Uh, where is that? Where is that? Okay. Okay, we are back here. Okay, so for the system to understand, what is happening. Okay, you need to provide two other than them. You need to provide two things: slope and I mean, this is the internal part. The system will automatically do. You will not do it. But you need to understand this is happening. Okay. So the pixel, there is a pixel here, there is a pixel here, then there is a Bajuwala pixel. Okay. So the value of this pixel is 30. Array. I hate this thing. So the pixel value here is 30. The pixel value is 80. Pixel value is 80. Now what is happening? Can you tell me?
Yeah, the flow direction is defined.
No. What is happening to the terrain? Deep dive like that.
It's uphill, like I mean to say.
But
Great.
how do you know how like okay
The pixel, the elevation value is from 30 to 80.
yeah, it is going like that. So the pixel, if a person standing here, how will he see? How will he see? It is extremely steep. Steep rise. So we called slope. This is called slope. From if I draw perpendicular here and at perpendicular like that, array perpendicular like that, the angle at which this is theta. The angle at which the slope is increasing is called steepness. We call it as slope data. We call it as slope data. At what rate the steepness is increasing or decreasing is slope data for us. For watershed delineation, that is what it is. Okay. Agreed. Okay. So how do you do that? There is a formula for this thing, cos theta to do, or else you just say opposite side by adjacent side, right? What is that? Tan? Yes. Tan theta, no? You do tan theta, you get these two values, you'll get a slope. Either you get that is in degrees or percentages. That is up to you. Okay, 96% rise. That means it is extremely steep rise. You can get the rise in degrees also. Okay, so this is steepness. Now comes the aspect. What is aspect? Which direction the slope is increasing or decreasing? Is it north direction, south direction? You know understood right that eight directions 1, 2, 3, 4, 5, 6, 7, 8 directions are there. No, how does the system will know which direction based on the slope? Now it will calculate based on the sun angle when the image was taken. Uh, the system will calculate. Okay, the slope is actually decreasing in east direction. So this direction image data is called as aspect data. Okay, it's called as aspect data. So the system will use this slope and aspect to calculate this 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is another important concept I forgot to explain you. So now I did. That should be fine. I hope you I hope you understood the basic concepts. That should be most important. Then I will share the share. Now, what is the time now? 9:40. Okay, I want to finish this video. So now I have this, you see this thing. So this is the boundary. If I okay, so because this is 30 meters, so there is slight error, but so this from here, if I draw a droplet on this pixel, it will go either here or here, in this direction or in this direction. So that becomes a boundary for the data. Agree? That becomes the boundary for the data. So that is the boundary I got. Agree? So for now, I will remove this thing. See, it follows the exact same shape. You see the curve nicely. So you can literally identify the terrain. By looking at the terrain, you can identify the boundary of the watershed. Okay. So now I have a data. Oh, sorry, a mistake. So I have the data here that can that is actually mosaic. So we have mosaic the data to so that there is no there is one major image. Now this image, this is smooth image. There is no boundaries. Now I will fill the data. How will I fill the data? For that you have two options. There are two types of tools you can use in ArcGIS. Okay, there are two types of tools. Amit, the concept is same. Okay, even if I use QGIS or ArcGIS, the concept is same. But if you are doing in QGIS, you will be looking at the tools. Okay, what is the name of the tool? Where is the tool? Okay, that I will show you. But I will not explain the concept again in that option also. Understood?
Yes.
Great. Wait.
Sir.
So now, see in the if you go to toolbar, you have two options here. Okay, one is you go here, spatial analyst. In this thing, you have something called hydrology and groundwater. Okay, this is for your groundwater. If you want to do any analysis on groundwater, you will use this tool. I really do not understand what is Darcy flow, Darcy velocity. I don't understand. But hydrology, this is what we use. Okay. Because I have not worked on ground flow, so I don't know. So this is the tools you use, or there is a special tool called as like how you have network analysis tool and spatial analysis tool. You have something called arc hydro tools. What we are going to use is that today, but the same tools are here also. Hydrology may you will find the same thing, but I prefer higher hydro because it has a stream flow. Nice stream flow you has okay. So you have this option here in this arc hydrology. You have these toolbars: watershed processing, utility, terrain processing. We will be using these two options mostly. Okay. I think I will talk about network tools also in this maybe next class, but you can also do HH modeling. Floodplain delineation you can do, map to map, and then stream stats you can calculate. Uh, you can do efficient by cell grid. I mean, you can try to do density map of where is the more flow, where is the more accumulation. You can do all of these things. Okay, but because that would be a highly advanced way of dealing with arc hydro. But I will only teach till watershed delineation and all. But this is a tool, you can use this tool. I think it is there in your RJS also, because the crack version has all of that. Okay. So there are two ways to do. First thing is always when you are trying to deal with arc hydro, come here in arc hydro setup, set up the target locations. Matlab you are trying to do arc hydro configuration, right? You are trying to do configuration of arc hydro. You create the input map name, as in you create whatever folder name you have or whatever type you have. This is default, you keep it like this. Then you input raster location. Matlab you are generating a raster location. Where do you want it to be stored? Okay, you have to create that. Then the system will also generate vector data. So you have to create a geodatabase. I mean, you don't have to do schema and all. Just simple. Create a geodatabase and use that here. You just have to browse to that like this thing. Click that, click OK, it will come here. Like that, okay? So you can set the target. Similarly, you can also set the batch processing targets also. This is very important. These two are very important. When you are working with arc hydro, these two are very, very important. If you fail to put this all the data in one particular locations, you will have a lot of errors. Literally lot of errors. Okay. So all the data for delineation, arc hydro, everything has to be in one particular location only. Okay. Then comes the attribute tools. In this attribute tool, what you do is once you get the network data, you will assign hydro ID. I mean, you will understand this thing, the unique, I mean, the importance of this thing when you are trying to deal with uh, flood analysis, storm water analysis, or flow, finding out the flow amount in the data in the streams. For all of that, you use this hydro ID or watershed ID. So you, for example, I have this drainage lines. Okay, this is a road network. I mean, water network data I got. Now, if I go here, attribute table, see I have arc hydro. Matlab based on this thing, every edge, every stream is mapped. Okay, so how much water is coming to this entire stream? All of that can be matched. So this is very important. So, but these are specific to advanced way of processing. If you're really specific only to use arc hydro, then I think you need to go into much deeper into discussing all of that. But I'm just giving a basic introduction here. Okay. Then there are models, feature count, which I mean, these are all basically about the streams. I mean, how many watersheds are there, all of that. Basic statistics. Okay, just click this thing, the process will happen. Okay. Now the another most important thing is this thing, terrain processing, morphology, terrain processing, terrain batch processing. Okay. In terrain processing, I mean these are all. See, you can add a once you have the river network, you can do network analysis for river path. You can just literally create like this entire thing can be like a road network. You can create a water hydro network and do different processes on that. So terrain morphology, basically you can model flip preferred path, preferential path, connect hydro junctions. Hydro junctions are nothing but the junctions where these networks meet. So these things are highly advanced way of dealing with the arc hydro. Arc hydro itself is a highly advanced tool. So it is up to you how much you want to deep dive. You have to do it on your own on this thing. So tenant property processing is here. In that, this is a DEM manipulation. This is where you do the field sinks, level DEM, sink elevation, I mean all that reconditioning of the DEM. What you have, what I taught, no, filling the errors, all of the DEM reconditioning you do here. There the tools are here. Okay. Similarly, you have vector quality check. Yes, this is especially useful when you do network analysis on the when you create a hydro network. Agreed? So I think today I'll only give introduction because it's already 9:50. My God. Okay. Anyways, so you do flow accumulation, flow direction here. Okay, you use this drainage line processing, drainage point processing. These things are really important. 1, 2, 3, 4, 5, 6. These tools are really important. Okay, for your watershed delineation because you can do the higher order only when this particular tools you use and the data is accurate. Stream definition and stream segmentation is also very important. This is where you define the stream. This is one stream, this is one stream, and then you do the stream segmentation based on the stream values. Okay, so you need to, I mean, we will, I'll tell you each how to use this when I get to the details. Okay. Now, there is the one interesting fact is, I mean, you can, ArcHydro gives you an option to use one particular tool for your data or use a batch process. We generally use this option, dendritic terrain processing. Okay, we use this thing. What is happening here? So if you see, this is called model developing. This is called model. Are you seeing my model here? Is it visible? The fill, flow direction, FDR, flow accumulation, and all. Are you seeing this? This four?
Yeah, screen is visible, but it's too small to appreciate it actually. Maybe. Yeah, now it's better. Yes. Good. It's correct.
See, the process is simple. It needs a filled DEM data. It uses the filled DEM to calculate the flow direction. It uses the flow direction to calculate the flow direction data. The flow direction data is used as input for several other processes. Okay, it is used as input to several other processes here. From the flow direction, flow accumulation will be calculated. From the flow accumulation data is calculated. From flow accumulation, stream network data is calculated. Then the stream data is segmented to form stream link data. Okay. What is stream link data? Okay. This is one stream, right? This is one stream, right? I'm Mr. Gupta. So this is one stream. Okay. This is another stream like this. Okay. This is where the link is happening. This is where the link is happening. Okay. So these things are stream links. Give me a second. Give me a second. Okay, so that is called stream link data. So this is linked to the stream. So that is what is created here. Okay. Then comes catchment grid delineation. So based on stream links, every stream link will have one watershed delineated. Then the catchment, I mean, that's what the catchment delineation happens. Then you can do two things simultaneously. One, you can develop a catchment polygon. What is catchment polygon again? The catchment polygon looks like this. Right. This is catchment polygon. See, because I developed stream link. So every link has its own independent watershed. Every link, every stream has its own independent watershed. Okay. And this entire thing is called as polygon. I mean, catchment polygon processing. So I converted the, sorry, my mistake. I should show you this thing actually. Where is the line? Yeah. You see that You see this? This is how the raster is developed. From raster, I converted to polygons. That is where I get this thing, the polygon. That is that. So you can do drainage point processing. Drainage point processing shows you drainage line processing. These two things give you the river network and the junctions. I mean the outlets of the drainage, outlets of the watershed. So these two are very important. I mean sub process you can do. Yeah, and then you have to do this. There is no other way. So this is the process it follows. Here you give number of cells to define stream. So this is where you give the flow accumulation value. See, if it is above 10,000, it's important for me. That's what you give. So based on that, the stream definition is developed and the stream network or this is done. So this is the flow of this entire system. So you can just come here, do the fill data. You can click this thing automatically. It will run automatic batch process. It will run. It will provide. It will generate all this data for you directly. There is no other. You don't have to do anything. Okay. Then there is dendritic. Oh, sorry, deranged. Edit. See, in deranged, you have the same thing, almost same thing. See, you have. I'll first zoom in here so that you have them. You fill sing. From fill, you take the deranged connectivity characterization. So basically, you will have the where is the flow direction? Flow direction. Then you have the sink point. All this thing you can do all of this thing. Catchment polygon, drainage. All this thing is same. But what happens is you will generate this connectivity characteristic, and also you use the sink evaluation, sink polygon, sink drainage area to do dem reconditioning. So what you are doing here and here is you are doing dem reconditioning, and based on that you get this, you process this value, you get this drainage connectivity properly, and then you. I mean, I want you to try this thing. Okay, you try these two tools to find what and how the data is different. How you get the hydro junction, hydro edge as an output. You don't have to do anything else. This is much more complete process. Drainage. Sorry, not drainage. Sorry, it's a deranged process. Okay. This is a much more complete process. But this is for heavy users, and especially when you are trying to do network analysis on water body, like how much water is, if there is a flood at one junction, how much water will end up in other junction, at what speed. For that you use this. So that is called deranged. Today I will end here only because it's already 9:56. Okay. Agree?
Yeah.
So I'll stop it. First I'll stop the.
Yeah.